Hello everyone. So for today's session, we will be learning how to get the sum of the interior angles of a given polygon. So let's start. Interior angles of a given polygon. So what is an interior angles? So we define as an angle formed inside the two adjacent sides of a polygon. So I have here the figure on the screen. As you can see, this is an example of one polygon. This is hexagon because it has 6 sides. So when we say interior angles, these are the angles formed inside our polygon. So today we will be learning how to find interior angles, specifically the regular polygon. So what is a regular polygon? When we say regular polygon, this is a polygon that is equilateral and equiangular. When we say equilateral, all the sides are equal. When we say equiangular, all the angles are equal. Such as, we have example square, equilateral triangle, and many others polygon. So first, let's have this first polygon, triangle. A triangle, as we all know, is composed of 3 sides, 1, 2, and 3. Also composed of 3 vertices and 3 angles. This angle, second, and the third angle. So of course, to get the interior angles of this triangle, so we have here the sum of the interior angle is 180 degrees. Meaning to say, if you are going to add this angle here and here, the sum of their angles is always 180 degrees. So supposing we are given the second example, a square. A square is one example of what we call quadrilateral. So we have here a square, 4 sides, 4 vertices, and 4 angles. If we are going to draw a diagonal line, this is what we call the diagonal line. So the question is, how many triangles formed out of this figure? So here, as you can see, there are 2 triangles formed out of our square. So again, one triangle, we have here, to get the measure of the interior angle of one triangle, that is always equal to 180 degrees. How about the second triangle? So of course, getting the interior angles, getting the sum, we have also 180 degrees. Since we have 2 triangles formed in our square, what are we going to do is to add 180 plus 180, so we have 360. Or you can have 180 times 2, that is equal to 360. Next example. Suppose we are given another polygon. This is what we call pentagon. When we say pentagon, it has 5 sides. So again, out of this pentagon, we are going to draw a diagonal lines. Here, first diagonal, second one. So after adding a diagonal lines, how many triangles formed? So we have 3 triangles. And again, one triangle getting the interior angles, you are going to add all the angles, that is equal to 180 degrees. The second triangle, adding all the angles, we have 180 degrees also. Next, the last triangle. to get the sum of the interior angles, you have 180 degrees. Meaning to say, since we have three triangles, we are going to add 180. So we can say 3 times 180. So we have here, the answer is 540. 540 degrees, rather. Okay, next, we have hexagon. So when we say hexagon, it has 6 sides. 1, 2, 3, 4, 5, 6. Out of our hexagon, we are going to draw a diagonal lines. So first, we have here, second diagonal, and the third diagonal. Okay, as you can see, how many triangles formed after adding the diagonals. So we have here 1, 2, 3, 4. So we have 4 triangles. So again, in one triangle, to get the interior angles, so of course this is 180 degrees. Same with the second triangle. Getting the sum of the interior angles, we have 180 degrees. The same thing with our third triangle. Getting the sum of the interior angles, it will give us 180 degrees. Lastly, we have to get the sum of the interior angles of the last triangle. We have 180 degrees. Meaning to say, apat ka 180 ang i-add natin. So we can also say that 180 times 4, we can have 720 degrees. Meaning to say, the sum of the measures of the interior angles of our hexagon is 720 degrees. Next. So, supposing we are given decagon, dodecagon. So, aside from adding the diagonal lines and how many triangles formed out of that figure, we can use this formula. So, we have here number of triangles, number of sides, minus 2. Then, to get the sum of the interior angles, you are going to subtract 2 with the number of sides, then multiplied it by 180 degrees. Again, when we say n, that is referred to the number of sides of our polygon. Supposing we have here first example. So in our first example, we are given hexagon. Again, the hexagon, we have, this is composed of 6 sides. So to get the sum of the interior angle of our hexagon, so we are going to follow this formula, n minus 2 times 180 degrees. Again, our n refers to the number of sides of our given polygon. So, since our hexagon is 6 sides, so we are going to substitute in our n. So, we have here 6 minus 2 times 180 degrees. So, 6 minus 2, we have 4. After that, multiplied it to 180 degrees. So, we have 720 degrees. So, meaning, without adding the diagonals and getting all the triangles out of our figure, we can get the interior angles, the sum of the interior angles of a given polygon based on our formula. So, I'd like to emphasize that 720 degrees is the sum of all interior angles of our hexagon. But supposing our hexagon, okay, as you can see, this is a regular polygon because all sides are equal. And all angles are equal also. So again, getting the sum of the interior angles, you can have 720 degrees. But the question is, what if you are going to find each angle? So here's the formula. Measure of each interior angle of a polygon. So again, here, n minus 2 multiplied to 180 degrees divided by our n, or the number of our sides. So, since we have a hexagon, 6 sides, just substitute to our n. We have here 6 minus 2 times 180 degrees divided by 6. Next, 6 minus 2, we have 4. 4 times 180 degrees divided by 6. So we have 4 times 180 is 720 degrees divided by 6. Final answer is 120 degrees. Meaning to say, each angle of our hexagon measures 120 degrees. So you have here, each angle we have 120 degrees. Okay, as you can see. Then, getting the sum of all the angles of each angle. So, you have 720 degrees. Okay, next example. Supposing we are given this figure, a rhombus. Again, a rhombus is an example of a quadrilateral because it has 4 sides. So, again, without adding the diagonal and getting all triangles out of our figure rhombus, we are going to use the formula. So sum of the interior angles, again, n minus 2 times 180 degrees. Since the number of sides of our rhombus is 4, just substitute to the number of sides. 4 minus 2 times 180 degrees. 4 minus 2 is 2. So 2 times 180 degrees is 360 degrees. So, the measure of all angles, or the sum of the measure of all angles of our rhombus is equal to 360 degrees. Next, how about if you are going to get the angle of each, to get each angle of our rhombus. So again, we have the formula, just substitute. 4 minus 2 times 180 degrees divided by 4. So 4 minus 2, we have 2. 2 times 180 degrees is 360, then divided by 4 because we have 4 sides, that is our n. 360 divided by 4, we have 90 degrees. Meaning to say, each angle of our rhombus measures 920 degrees. Sorry, 90 degrees rather. So we have here 90 degrees, 90 degrees, and 90 degrees. So getting the sum of the interior angles of our rhombus, we have 360 degrees. So I have here the summary. Interior angles in a regular polygon. So for today's session, we are focusing only in getting the interior angles of a given regular polygon. So we have the equilateral triangle. Total is 180 degrees and each angle measures 60 degrees. We have the square. The total interior angles is 360 degrees and each angle measures 90 degrees. We have the regular pentagon. The measure of the interior angles is 540 degrees and each angle, isa ka angle, the measure 108 degrees. Okay? So for regular hexagon, the sum of the interior angles of our hexagon is 720 degrees and each angle of the hexagon measures 120 degrees. Same thing with our heptagon. The interior angles of our heptagon is 900 degrees and each angle of our heptagon is 128.5 degrees. And lastly, we have the regular octagon. The sum of the angles, the interior angles of our octagon is 1080 degrees. And each angle of our octagon measures 135 degrees. Here on the left side, you have there the formula. So, that's end for our topic for today's session. Thank you and goodbye.